boiling point, atomic radii, enthalpy, and flame test, photoelectric effect. Any doubt is there in that photoelectric effect flame test? Please, can you, any doubts? Can I teach once flame test or photoelectric effect? Please, you need to ask. Any doubts? Let me know any doubts is there, please. Please tell me any doubts is there? Or shall I continue chemical properties? Can I start chemical property?
You can continue.
Hello?
You can continue.
Yeah. Chemical properties, please note down. Chemical properties of S block element. The chemical properties of S block element. First one, reaction with air. Reaction with air, I can say reaction with air. When lithium react with air, will give rise to Li2. This is called oxide, monoxide will form. Oxide, only oxide will give. Lithium will give only. When lithium react with oxygen, will give rise to lithium oxide. So to balancing purpose, I am going to writing year 2. Then I am going to writing year 4. Because of oxygen 2 is there. If you write year 2, 2 2s are 4. 4 lithium we need to write. Lithium only forms oxide. Next, sodium react with oxygen will give rest. In the limited amount means sodium will react with the limited amount of oxygen will to oxide. Na2 oxide will form. Na2O will form. To balancing purpose, I am going to writing here 2. So here we need to write 4. So sodium oxide, lithium oxide. Suppose if sodium react with the excess amount of oxygen, to balancing purpose, that's it. So when limited amount oxide will form, when excess amount peroxide will form. Same thing when I'm going to potassium. Potassium mainly will form potassium react with oxygen, excess amount of oxygen will give rise to KO2. KO2 is called what is that? Superoxide. KO2 is called what is that? Superoxide will form. So here remaining lithium will react with excess amount of oxygen will give rise to RbO2 superoxide. Cesium react with oxygen, excess amount of oxygen will give rise to CSO2. Cesium superoxide, rubidium superoxide, potassium superoxide will form. But lithium will form only oxide, sodium will form peroxide and oxide, but potassium will form oxide, peroxide, superoxide also will form. Rubidium oxide, peroxide, superoxide will form. Cesium will form oxide, peroxide, superoxide will form, but mainly will form superoxide. So you need to remember wherever oxide linkage is there, their oxygen oxidation state is -2. Wherever superoxide, peroxide is there, oxygen oxidation state is -1. Wherever superoxide is there, their oxygen oxidation state is -1/2. I hope these points are clear. I will write in the next page. What is the general formula for oxide? General formula for peroxide, general for superoxide. I hope these points are clear here. Lithium will form only oxide. Sodium will form oxide, peroxide. But potassium, rubidium, cesium will form 3 types of oxides: oxide, peroxide, superoxide. But mainly will form superoxide. What is the formula for superoxide? KO2, RbO2, and CSO2. Those are called superoxide. Wherever oxide is there, their oxygen oxidation state is -2. Wherever peroxide is there, their oxygen oxidation state is -1. Superoxide is there, their oxygen oxidation state is -half. Is it clear? Hello?
So once again, can you write that?
Yeah, I'll write that one. Please complete this part. Once you're done, you can inform to me, please. Once you complete, you can inform to me.
Done, sir.
Present general formulas. See, oxide general formula. Oxide general formula M2. Oxide means oxidation state is -2. Oxide general formula. So like Li2, Na2, K2, Rb2, CS2. This type of oxides will form. Lithium oxide, sodium oxide, potassium oxide, rubidium oxide, cesium oxide. Here oxygen oxidation state -2, -2, -2, -2, -2. For two lithium, each lithium plus one oxidation state. For two sodium plus two, each sodium plus one oxidation state. So this is the general formula for oxide. Suppose if you want to write peroxide formula, peroxide means M2O2 type of formula. Wherever peroxide is there, there -1 oxidation state for oxygen. So lithium does not form peroxide. So sodium peroxide, potassium peroxide, medium peroxide, and cesium peroxide. This is the peroxide formula. So next, superoxide. Wherever superoxide is there, their oxygen oxidation state is -1. Formula MO2 type of formula. M2O2, M2O, this is MO2. So here generally lithium and sodium does not form superoxides, only potassium will form superoxide, will form superoxide, and cesium will form peroxide. Here minus of is the oxidation stage. Minus of. Potassium is +1, rubidium is +1, cesium is +1. So for two hydrogen atom, two oxygen atom minus, each oxygen atom minus of. Now is it clear?
Yes, sir.
Please complete. Next chemical property react with nitrogen. So generally alkali metal yes,
The last line is stability, right?
I will write in the next page. Stability of peroxide and superoxide. This is solubility. So which is more soluble in water? CH2O is more soluble in water. Li2O is less soluble in water. This is more soluble in water, less soluble in water. This is less basics, this is more basic strength of oxide. Now I am going to stability of peroxide and superoxide. Stability. Peroxide and superoxide. You know very well what are the peroxides will form and what are the superoxides will form. Peroxide Li2O2, Na2O2, K2O2, Rb2O2, and CS2O2. This is the peroxides will form. So actually Li2O2 will not form. Na2O2, K2O2, Rb2O2, CS2O2. This type of peroxides will form. What are the superoxide? This is peroxide. What about superoxide? Superoxide, which one will form superoxide? It's KO2 superoxide, RbO2 superoxide, CsO2 superoxides will form. So what is stability order? Stability down the group increases. That means stable peroxide CS2O2 is more stable peroxide Na2O. React with halogens will form. Metal halides will form.
Sir, when did the class start, sir?
Class started 2-5.
This is which chapter, sir?
S block elements. Once you're done, you can inform to me. I'll go to next one. Completed. Hello.
Yes.
So what are the types of halides will form? Please listen. So LIX type of halide, NAX type of halide, KX type of halide, RBX type of halide, and CSX type of halide. X means halogens. This type of halides will form. So now I am going to asking one more question. Please listen. This question is most important. So you know Fazan's rule. Already we discussed the Fazan's rule. Fazan's rule means, listen, ionic character is directly proportional to size of cation. Cation size increases, which character increases? Ionic character increases. I already told you in the LIX, X is negative charge, Li is positive charge. X is negative charge, Na is positive charge. X is negative charge, potassium is positive charge. X is negative charge, Rb is positive charge. X is negative charge, Cs is positive charge. Ionic character is directly proportional to size of cation. Cation size increases, which characters ionic character increases. Ionic character, suppose if it is depends upon anion means size of anion, inversely proportional to size of. What is the meaning of inversely proportional to size of anion? Anion size is large, then which character will be decreases, ionic character will be decreases. Anion size is small, then which character will be increases, ionic character will be increases. Next, suppose if you want to calculate covalent character is directly proportional to size of anion. Anion size increases, which character increases, covalent character increases. Covalent character is inversely proportional to size of cation. Cation and covalent character is inversely proportional. One more covalent character is charge on the ion. Ion charge increases, covalent character increases. That's why I'm going to telling here what lithium has more covalent nature. More covalent nature. Lithium halides are more covalent nature, but CXS as what type of nature? Ionic nature. Ionic in nature. Lithium halides are more covalent in nature. CSX are more ionic in nature. Please note this point. I'll tell you some more detail now. Did you understand Faison's rule? How, see, cation size is more, which character will be that one? Ionic character. Anion size is more, which character that one? That will be the covalent character. If anion size is small, then it will be the ionic character. Size of anion, covalent character. Anion size increases, covalent character increases. Cation size decreases, covalent character increases. Cation size increases, ionic character increases. Covalent character is directly proportional to charge on the ion. Either cation charge increases or anion charge increases. Which character will increases means covalent character will increase. Let me go for some examples for that. Can I take examples? Can I take example? Hello?
Yes, sir.
Please listen. Now I am going to taking this one, LIX, NAX, and KX, RBX, CSX. I taken this one. I already told you X minus Li plus, X minus Na plus, X minus K plus, R minus RB plus, X minus CS plus. So now I am going to tell you. So based on anion, we can't calculate whether it is ionic character or covalent character. Because of anion is same, everywhere is same. So that's why we need to take this one. Li plus, Na plus, K plus, Rb plus, CS. Size of cation increases. Is it correct? Sorry, size of cation increases down the group. Is this correct? This is large size cation. This is small size cation. Li plus is small size cation. And CS plus is large size cation. Large size cation. Among these two, which is more covalent character, which is more ionic character? Can you tell me anyone, please? So this point you know very well. Ionic character is directly proportional to size of cation. And ionic character, sorry, covalent character is directly proportional to size of, inversely proportional to size of cation. Can you tell me these two statements based on which is covalent character, which is ionic character? You need to respond, please. Li plus is what type of character? CS plus is what type of character? Li plus is small size cation, CS plus is large size cation. So I told you ionic character increases with increase in size of cation. Covalent character decreases with increase in the cation charge. If cation size increases, covalent character decreases. If cation size decreases, covalent character increases. Please tell me Li plus is what type of, CS plus is what type of character? You need to respond, please. For given alkaline halide, given alkali metal, if you respond, then only I'll go. MF, MCl, MDR, MI. Among these three, which is more covalent character, which is more ionic character? Can you tell me? Please respond. Hello?
Yes, sir.
Which is the first one? Lithium plus is what type of character? CS plus is what type of character? Please tell me.
Sir, how do we know the size of cation?
Size of cation, you know, down the group size, what will happen? In the group,
Yes, sir.
down the group, what will happen?
Size will increase.
Size will increase means Li plus is small size cation, Cs plus is large size of cation, correct?
Yes, sir.
So then can you tell me one by one? Li plus is what type of character? Cs plus is what type of character? Li plus is covalent character. Cs plus is it correct?
Yes, sir.
Why? Ionic character is directly proportional to size of cation. Among these alkali metals, which is more size, Cs plus is more size. So that's why Cs plus is ionic character, Li plus is covalent character. So that's why I told you LIX is more covalent character, CSX is more ionic in nature. While coming this example, MF, MCl, MBr, M means metal atom. Here metal atom is same. Suppose LIF, LICl, LIBr, LIFI. So among this, which is more covalent character, which is more ionic character? How to define? Same thing, Li is common. Based on cation, you can't calculate. Based on anion, you can calculate F minus, Cl minus, Br minus, I minus. In the down the group, atomic size increases. Down the group, atomic size increases. Here, F minus is small size of anion, I minus is large size of anion. Now, while coming the Fazan's rule, so covalent character is directly proportional to size of anion. Anion size increases, covalent character increases. Ionic nature is directly proportional to, inversely proportional to size of anion. So F minus is small size anion and I minus is large size of anion. So if it is large size of anion, which character increases? Covalent character increases. If small size of anion, which character increases? Ionic character increases. So down the group, covalent character increases. Understand now. MF, MCl, MBr, Mi. Which is more covalent character? Mi is more covalent character. MF
Sir,
is
M is lithium.
yeah, LIF is large ionic character. Li is more covalent character. Correct.
Okay.
So now while going like this, what character increases? Covalent character increases. Or no? Is it clear? Please respond. Hello.
Yes, sir. Yes, sir.
If you have any doubts, I will take one more example. Can I take one more example?
Yes, sir.
Yeah, I will take now one more example. Please listen. Can I erase this page?
Yes, sir.
Please listen now. Suppose I am going to take it here. LICL, NaCl, RBCl, KCl, RBCl, and CSCl. Can you tell me anyone which is more covalent character, more ionic? Which one is more ionic character? Which one is more covalent character? See, one point you need to remember. See, based on anion, we can't decide. Is it correct? Based on anion, we can't decide because of Cl minus, Cl minus, Cl minus, Cl minus, Cl minus. But based on cation, you can decide because of different cations. Yeah, one is Li plus, another one is Na plus, another one is Ka plus, another one is Cs plus. So now we can decide. So down the group, size of cation increases. Size of cation increases. Is it true or not? So now you know the Fazan's rule. Ionic character is directly proportional to size of cation, and covalent character is inversely proportional to size of cation. So size is more, size is less. That's why I'm going to write it small size cation. This is a large size cation. Large size cation means this is called ionic nature. Small size of cation means this is called covalent character. So LiCl is covalent character, CSCl is ionic character. So that's why I told you down the group ionic character increases.
Sir, then what about NaCl and KCl? What are they ionic or covalent character?
This ionic. Down the group ionic character keep on increasing.
Okay, sir.
Suppose I am going to taking like this. For example, NaCl, NaF, NaCl, NaBr, NaI. Suppose I am going to taking like this. Here common, cation is common. Cation is common. So based on cation, you can't decide whether it is ionic character or covalent character. So based on anion, you can decide F minus, Cl minus, Br minus, I minus. So down the group, size of anion increases. Is it true or not? Yeah. Now, what is the relation between ionic character and anion? Ionic character and anion is inversely proportional. Covalent character and anion is directly proportional. So now can anyone tell me which is more covalent character?
Covalent is NaI.
NaI is covalent character. Which is more ionic character?
NaF.
F is the more ionic character. Is it clear now?
Yes,
Still
sir.
any doubts is there? Hello?
Yes, sir.
Yeah, please complete fast. Once you're done, you can inform to me and go to next one. Yes. Now, please listen. Some more preparation for halides. What are the other preparations? Another preparation. Suppose these halides can be these halides. These halides can also be prepared by the action of aqueous halogen acid HX. Aqueous halogen acid HX on metals metal oxides, hydroxides, carbonates. Oxide, hydroxide, carbonate. Metal oxide react with HX. What is the product? Metal hydroxide react with HX. What is the product? Metal carbonate react with HX. What is the product? So metal oxide react with HX. MX will form. Metal halide will form. Plus H2O will form. To balance this equation, 2HX, 2MX. Metal hydroxide react with HX. Metal halide will form plus H2O. So metal carbonate react with HX. Metal halide will form plus carbon dioxide will form plus H2O will form. To balancing purpose, 2mx, 2hx I'm going to. So where M is equals to lithium, sodium, potassium, rubidium, cesium we are going to use. X is equals to fluorine, chlorine, bromine, iodine you can use. So this is the some other preparations of metal halides. I hope these points are clear. Yes or no? Let me know please. Once you complete, you can inform to me. I'll go to next property. Reducing nature. Reducing nature is the next property. Generally, alkali metals are strong reducing agents. Please note in whole periodic table, alkali metals are strong reducing agent. Alkali metals are strong reducing agent. In whole periodic table, lithium has strong reducing agent. Because of it has low SRP value, standard reduction potential value. SRP means what? Standard reduction potential value. Lithium is the strong reducing agent in the whole periodic table. So what is the reason for strong reducing agent? Because of it is low reduction potential value. SRP means low reduction potential. Standard reduction potential value for lithium is least, that's why it's called strong reducing agent. What is the order of reducing agent? Which is more reducing agent in one periodic table? Lithium is more reducing agent. Then compare with rubidium, then compare with cesium, then compare with potassium, then compare with sodium. This is the order of reducing agent for first year group element. Lithium, rubidium, cesium, potassium, sodium. Still any doubts is there? Please let me know.
Sir, why is helium not there in F block?
Which one?
Helium.
Helium is not there in S block.
Yeah, why it's not coming in this? Sir?
So it is a noble gas. Helium atomic number it is 1s2. Is that correct?
Yes, sir.
So helium is completely electronic configuration. It is noble gas. Is it correct?
But it's still S, right?
Yes, so this is exception case. Hydrogen and helium. So hydrogen it has similarity with first state, but it has similarity with first state. So that's why the position of hydrogen is still as confusion. It is not the first state group, but it belongs to some state group. But helium is the noble gas. Helium is the completely electronic configuration. One is not only this thing.
Sir, we are concluded class.
Yeah, helium is noble gas. Helium, neon, krypton, red. This belongs to noble gas. This is but this configuration is positive. Configuration is positive. So 1s2 means the first helium. Yes, second group, but this is not the answer is that noble gas. Noble gas is one point.
Okay, sir. Thank you.
Email when you discuss the next.
Okay.
Thank you.
Thank you, Dr.
Thank you.